Welcome to the world of mathematics. So what is algebra tiles? These are colored blocks that helps to represent algebraic expressions or equations. With these tiles, it gives support to the representation and manipulation of the different algebraic expressions. There are three types of algebra tiles, which are the large square, the rectangle, and the small square, which are divided into two, the positive signs and the negative signs. In mathematics, there are many solutions but lead to one answer.
Problem solving in algebra tiles involves using physical manipulative tiles to represent and solve mathematical problems. By manipulating these tiles, students gain a hands-on understanding of complex algebraic tiles such as equation, operation, and expressions.
Hands-on learning with algebra tiles involves using physical manipulative objects to represent mathematical concepts in algebra. In this approach, students physically manipulate tiles with positive and negative values to represent algebraic expressions, equations, and operations.
Developing mathematical reasoning with algebra tiles involves engaging students in activities that encourage critical thinking and logical analysis. By manipulating tangible tiles to represent algebraic expressions and equations, learners develop a deep understanding of mathematical relationships.
Visualization in algebraic tiles refers to the use of physical colored tiles to represent algebraic expression or equation. By manipulating these tiles, students can visually grasp abstract concepts such as adding and subtracting, terms, factoring, and solving equations.
How about we try identifying algebraic expressions or equations? But first, let's get to know what these three types of tiles that are being presented. The big blue square is x squared, the green rectangle is x, and the yellow square is the constant. And behind all of these algebra tiles are in the color red, in which it represents negative.
For example, let's have a big blue square first, but flip to the red sides. Two green rectangles besides it. Then finally, four small yellow squares. What expression does this represent? The answer is negative x squared plus 2x plus 4. Good work! It seems like you had already understood. In identifying algebraic tiles, let's move on to the problem solving.
A one-step equation is an algebraic equation you can solve in only one step. Once you solve it, you found the value of the variable that makes the equation true. First, let's make a line. And above this line, we'll write our equation 4x equals 8. Underneath the equal sign, draw a line coming down to divide the two sides of your equation. Next, use the algebra tiles to model the equation on each side. Then, I'm going to take the x tiles and divide it into 4 equal groups of 1x each. Now, whatever we do to the one side of the equation, we must also do the other side. Now, we can see that in each individual x is equivalent to a group of 2 unit tiles. In other words, x equals 2.
Multi-step equations are algebraic expressions that require more than one operation, such as subtraction, addition, multiplication, division, or experimentation to solve. It is the same as one-step equation. So first, let's have our equation. 2x minus 2 equals negative 4. We'll start by modeling it with algebraic tiles. In this case, we have these two negative constant tiles, and how are we going to get rid of them? Well, add two positive tiles in order for them to cancel each other out. And we'll also do the same to the other side because that is the rule applied towards algebraic tiles. Lastly, we're going to divide the x and constant into two equal groups, concluding that x is equivalent to negative 1.
In combining like terms will simplify a math problem and is also the proper form for writing a polynomial. To combine like terms, just add the coefficients of each like term. First, let's start out by modeling our polynomials or equation with algebra tiles. 2 positive x squared plus 1 positive x plus 6 constants, and plus negative x squared plus 4 positive x minus 4 constants. Now, with algebra tiles, combining like terms is the same thing as combining like tiles. We'll just pair up positive and negative tiles in order for them to cancel each other out. In conclusion, by canceling the positive and negative pairs, we can see that the remaining tiles are 1 positive x squared plus positive 5x plus 2 positive constants. Therefore, the answer of this equation is x squared plus 5x plus 2.
Let's have our equation. X squared minus 3x plus 1, given that x is equals to 2. And we'll start by modeling our equation. Here, in the constant, we'll be leaving this alone because it's already a number. And now, we know that x is equals to 2. We will replace the negative x tiles but with two negative constants as well, and apply it to the rest of the x tiles. Finally, we're left with x squared. We'll build a square that is x unit wide and x unit long. Since x is equals to 2, let's build a positive 2 by 2 squared to replace the positive x squared. So once all the variables are gone, all that is left to do is to find the combined values of all of these tiles. Let's start out by pairing positive and negative pairs and canceling those out. And now, I'm left with one negative constant tile. Therefore, when this expression, x is equals to 2, the value is negative 1.
X squared minus 3x plus 2. Factoring is finding what to multiply together to get an expression. It is like splitting an expression into a multiplication of simpler expressions. First, let's create a multiplication table. To draw a multiplication table, we need a vertical line and then add a horizontal line at the top. Next, let's model the algebra tiles. 1 positive x squared, 3 negative x tiles, and 2 positive constants. And we need to arrange this in the multiplication table so that we can get a complete rectangle with no holes, in which it is the opposite of expanding expressions. Next, we always put the x squared tile in the top right hand corner, and our constants are always in the bottom right. And now, we're going to use the 3 negative x tiles to fill in the holes or spaces of the presentation, like this. Now we have a completed rectangle, known as area model, that represents our equation. Now we're going to find the answer based on the length, width, and sign of the equation. We can see on the top, 1 positive x squared and 2 negative constants, while on this side is 1 positive x squared and 1 negative constant. Therefore, the answer of our equation is x minus 2 and x minus 1.
That's all. Thank you and goodbye.